Hello, sir. Can you hear me?
Yes, yes, I can hear you properly. Okay, today we try to understand another new things, probability for exclusive and independent events. Exclusive means mutually exclusive, and another one is independent. Okay. Uh, at first, try to understand what is mutually exclusive and what is independent. Two events are mutually exclusive if they cannot occur at the same time. Two events are mutually exclusive if they cannot occur at the same time. Example, selecting an even number. Selecting an even number or selecting a 1 from a set of numbers. That one is mutually exclusive. Like if you draw, okay, you are doing maths class. At a time, maths class and physics class. At a time, you can't do maths class and physics class. If you do maths class now,
Okay.
you can't do physics class now. So if you do maths class, you have to stop physics class now. So both of these classes are mutually exclusive, right? Understand? Okay.
Yes, sir.
So mutually exclusive means like if you throw a dice, like six-sided dice, if you want even number, like even number, you are searching for even number. At a time, you will not get the odd number. So if you want, like if you want even number and also one, you will not get this thing same time. Whether you will get one is odd number, even number is 2, 4 like this. Okay. So mutually exclusive is if two events cannot occur at the same time. This is mutually exclusive. Is it clear? Is it clear? Hello?
Yes, sir.
That means,
Sir, could you explain it again?
yeah, the two work like math class and science class, physics class. At a time, you can do both of these at a time. So both of these work is mutually exclusive. Understand? If two
Yes,
work,
sir.
if two work you can't do at a time, that one is mutually exclusive. Understand? If two work you can't do at a time, that works are the mutually exclusive. Understand? Like at a time you can't get the even number and one. Even number is all two fours like this. One is odd number. So at a time you will not get whether you will get even number, whether you will get odd number. When you get even number, you will not get one, right? Understand? When you get even number, if you get even number, will you get one over there? No. But
No.
when you get one, this is odd number. This is not even number. So both of these are mutually exclusive. Understand, right? Is it clear?
Yes.
Okay. So, Aryan, is it okay? Aryan, is it okay?
Yes.
Okay. Two events are mutually exclusive. They cannot occur at the same time. This time we will use OR rule. OR rule. For mutually exclusive or exclusive event A and B, we have to use the probability of A or B. Probability of A or B. Whether probability of A or probability of B. So this time both of these probability will be add. Probability of A plus probability of B. So OR rule give us addition of two probabilities separately. Probability of A or B equals to, we have to write probability of A plus probability of B. Like probability of even or on 1. So the probability of even plus probability of 1 like this. Understand? So this is mutually exclusive. So is it clear, I think? Is it clear, everybody?
Yes, sir.
Okay.
Yes, sir.
Second one. Two events are independent if the occurrence of one event is unaffected by the occurrence of the other. Two events are independent if the occurrence of one event is unaffected by the occurrence of other. Like you are doing maths class and you are drinking water. One work will not affect the other work. Both of this work you can do together. So this is independent. One work will not hamper others' work. That one is independent, right? Is it clear?
Yes, sir.
You are doing maths and
So a coin, we can get both at the same time, which will not hamper each other.
yes, that one is independent. That one is independent, right? Okay.
Yes.
Like when you are doing, when you're personally doing maths, you are doing maths and listening song. Both are independent because one is not hamper others. Okay, understand? Is it
Yes.
clear? Okay. Now here is another very good example. Obtaining head, head and head you will get from the coin, right? Obtaining
Yes.
head on one coin and tail on another coin when coins are tossed at the same time. Like you are throwing two coins. You are throwing two coins. From here, if you get head, another coin, you may get tail or you may get head, anything. It will not affect this one, right? Is it clear?
Clear, sir.
Or another example, another good example, like you throw the coin and throw the dice. Dice, we know the dice have the six part. 1, 2, 3, 4, 5, 6. If you get from this coin head, will it affect here in the dice to getting 1, 2, anything? Will it hamper anything to get from here? Uh,
No, sir.
no. If you get from the coin, you may get head or tail. Dice, it may get 2, 3, 4, anything. This head or tail will not affect the dice, right? So both are independent. Is it okay? Malia, is it okay? Afia, is it okay?
Yes, sir.
Yes, sir.
This coin
Yes,
throwing
sir.
will not affect the dice. From the dice, which one come, it's not affected, right? So here for independent events, you have to use the AND rule. Product of A and B, we have to multiply. Product of A multiply product of B. So keep in mind, OR rule, A or B, when we use this, when it is mutually exclusive. What is mutually exclusive? When we can't do both of these work together, that one is mutually exclusive. This time we will use OR rule, that means both of these priority addition. And when both of these events are independent, independent means one obtaining one thing is not affect another one, that one is independent. And here we will use the AND rule. Product of A and B is product of A multiply product of B. Is it clear? Right?
Yes, sir.
So it is addition rule for mutually exclusive. ADDI addition rule. And for independent, we have to use the multiplication rule. It is said to be multiplication rule. Okay. So after my class, you try to review yourself. Okay. Now see. One ball is selected at random from a bag containing 5 red balls. 5 red balls, 2 yellow balls, 4 white balls. 5 red, 2 yellow, and 4 white. 5 plus 2, 7. Total ball is total. Total is
11.
11 ball. Okay. Find the probability of selecting a red ball or a white ball. The two events are, so red ball will not affect the white ball. So this is OR rule, probability of red or probability of white, right? Probability of red, both are mutually exclusive. Yes. Okay. Both are mutually exclusive. If red come, white will not come. Two events are exclusive, not independent. If you throw the ball, if red come at a time, one time, white will not come. But when white come, red will not come. Understand? So these are mutually
Yes,
exclusive,
sir.
not independent. Understand?
Yes, sir.
So we will use here probability of red plus probability of white. So we know that for probability, if you want to find out the probability of red, total ball in the below side, what is the number of red? 5. Here 11. What is the number of white? 4. So after that, this 9, 11. Is it clear? Is it
Yes,
clear?
sir.
So at first, our holy duty.
So either we will get one red or one white if that probability is 9 by 11.
9 by 11. Yes, 9 by 11. Because this is mutually exclusive, so both of this probability will be add, right? Mutually exclusive. Because in one throw, logically you think in one throw, if red come at a time, you are taking one ball only, right? At a time, if red come, white will not come. But if it white come, red will not come. That's why this is mutually exclusive, right? Is it clear?
Yes, sir.
Okay. So the first example is over. The second one, see, a fair coin means the chances of come everything is same. A fair coin is tossed and a fair die is rolled. Fair coin is tossed, coin, and fair die. Die means this one. Fair die is rolled. Find the probability of obtaining a head and a 6. Two events are independent. Probability of head independent and probability of 6. So we know that if it is independent, that means head will not decide that from the die 6 come or not. Head will not decide. You are throwing head and coin and die. Head can't decide that from the die 6 come or not come. So both of them independent, so it will be multiplication. Probability of head multiply probability of 6. So probability of head means what? 1 by 2 multiply probability of 6 means Maliha? Oh no, Maliha, Afia. Probability of 6 means what? Afia? Afia? Or Maliha? Can you able to say Maliha? Probability of 6 is what? Confusion? Maliha?
I'm confused.
Okay, see. Okay, if individually probability of 6, if you want to find the 6, how many number here? 1, 2, 3, 4, 5, 6. Probability of 6 is what? 6 is how many
1
numbers?
by 6.
1 by 6. That's why it will be 1 by 6. Is it clear, everybody? Is it clear? Hello?
Yes, sir.
Okay, and what head is why? Head and tail, two things. That's why 2, head is 1, so 1 by 2. Is it clear, everybody? Is it clear? So in this math, the key point is to find out which one is independent. For independent product of A and B, that means both of this probability multiplication. And if it is mutually exclusive, both of this probability we will add, right? Like here, one math we try to solve. A coin is tossed and a die is thrown. A coin is tossed. So, okay, coin and die. So definitely both of them are independent. Write the probability of a head on the coin, a number. Probability of head on the coin is 1 by 2. Number B, probability of odd number, odd. Odd number is how many odd number? 1, 3, 5, 1, 3, 5, right? So 3 by 6, that is 1 by 2. A head on the coin and odd number on the die. Both of these are independent. So probability of head and odd number. So head probability is what? Probability of head multiply probability of odd. So head is 1 by 2. Odd is also 1 by 2. So it will be 1 by 2. Is it clear, everybody? Is it clear? If you revise, you will not forget on the short time. It's take a long time to forget these things. So try to remember these things and revise this is within 11 hours. Okay. Now see, number 2. A ball is selected at random from a bag containing 3 red balls. Red ball is 3 red balls, black balls, 4 black balls, and 5 green balls. And green ball is 5 green balls. So uh, 3 red, 4 black, 5 green. 12. Total ball is 12, right? This is total 12 balls. Okay. The first ball is replaced, and the second ball, the first ball is replaced, and the second is selected. Find the probability of obtaining 2 red balls. Okay, this is also very.
Sir, what does the first ball is?
This means this part is very important. This first ball is replaced, and the second is selected. So find the
Sir,
probability of.
shouldn't it be 1 by 16?
It will be 1 by 16. Oh, yeah, yeah. It will be 1 by 16. Yes. It will be 1 by 16. Yeah, 1 by 16. Yeah, 1 by 16. I have taken the first ball is red. So probability of red is 3 by, probability of red is 3 by 12. If I replace this, that means if I give it to the box again, my total ball is also now 12 and red ball is 3. So again, I have taken another red ball, so it will be 3 by 12. 3 3s are 9, 12 12s are 144, 9 cancel 144, it will be 16. So 1 by 16 is the probability of 2 red balls. Okay. Number
Got
B.
it.
Yeah, number B, 2 green balls. 2 green balls. Okay. So
Same way as red.
same way. If they don't say you anything, not replace, so you will think that this is replace. So probability of 2 green. The first green probability is what? 5 by 12. Second also 5 by 12. So it will be 25, 144, 25 by 144, right? Copy this maths.
Yes, sir.
If we do 2 work, if we can't do 2 work, if we start 1 work, another will be stopped. That one is mutually exclusive. Here we have to use OR rule or some addition rule. Product of A or B means product of A plus product of B. And independent means if 2 works, if we want to do one thing, another will not be affected. That's time it is AND rule. Product of A and B is product of A multiply product of B. So this is very important. You just remember these things. Now we want to start. So our next topic is tree diagram. Like, okay, tree diagram, this is one part, that one is one part. Okay, like, try to understand this maths. A bag contain 5 red balls, 3 green balls. So how many total ball? Total is 8 balls. Okay, 8 balls. And here red is 5, green is 3. A ball is drawn at random and then replaced. A ball is drawn and then replaced. Another ball is drawn. What is the probability that both balls are green? The branch mark star involves the selection of green balls twice. The probability of this event is obtained by simply multiplying. Okay. Now see, uh, this is like probability of red. Probability of red is 5 by 8. So if you find red ball, at a time you will not green ball. If you if one draw, if you get red ball in the same time, you will not get green ball. So both of these are mutually exclusive, right? Both of these are mutually exclusive. Is it okay? Is it clear?
So could you repeat it?
Yeah. Like, okay, here in the whiteboard, I try to write. Total ball is what? Red, like red is 5 red, green is 3 green. Okay. So total ball is 8 ball. Like if I draw the ball, if I want to take the ball, if I get red, like I get the red, so 5 out of 8, this is red ball. So when I get the red, this time I will not get green, right? So both of these are mutually exclusive. Is it clear? Right?
Yes, sir.
Okay. This is first ball drawn. This is first drawn. This is the first drawn. First drawn. First draw. Okay. First drawn finished. The second drawn, they said I also replace the ball. That means my total ball is 8. As I start by red, red ball also same. No less, same ball. But after red ball, if I want to take green ball, my total ball is same. And just now I started by green ball, so my green ball is 3. This is green. Remember, this is my second draw. This is my second draw. Okay. So in the first drawn, if I don't start from the red ball, if I start from green, what is the probability of green? 3 by 8. This is green. Okay, if I first drawn, if I get green, the second drawn, if I want to get the red, my total ball is 8. As I start from red, red is 5. No less. No less. But after green, if I in the second ball drawn, if I want to get the green, my total ball also 8, green also 3. Why 3? Because it's replaced. After taking this ball, I also again give the ball in the bag. That's why not less. So here most important part is replaced. Replaced. Everything will be same
What if
because,
it's not replaced?
oh, okay, later I will say. It is very important. If it is not replaced, definitely it will be less. Okay, understand? Hello?
Got it, sir.
Okay. Now this is the tree diagram. Is it clear? The tree diagram? Is it clear, everybody? This tree diagram? Is it clear? Hello?
Yes, sir.
Yes.
Okay. Now, if I want to find out, if you ask me, sir, probability of one red, one green. Probability of one red and one green. The first drawn red. Okay, wait just a minute. So, one red, one green, red and green. The first ball, if it is first ball red, second one green. So these are what? These are independent, right? These are independent. Red and green. Is it? The 5 by 8 multiply 3 by 8. These red and green, these are independent, right? These are independent because this red will not control this green. This red will not control this green. So red multiply green plus this part and that part is mutually exclusive, because if you get the first ball red, at a time you will not get the green. So this part, after this part, if you want to start this one, this is plus. That's why mutually exclusive. Green multiply red. So you have to write 3 by 8 multiply 5 by 8. So it will be 15 by 64 plus 15 by 64. It is 30 by 64. This is the answer. Please observe this math and ask me question, please. This red and this red, or this red and this green, are they independent or mutually exclusive? These are independent because this red, if it is come red, it's not affect this green. This red is not affect this green. That's why both of these are independent. And we know that for independent, we have to do multiplication. That's why we do multiplication over there. Product of red or what is that? The independent, what we said? Independent is n, right? Independent is n. That means multiplication. Is it clear, everybody? Is it clear? This part
Yes.
and this part is this part and that part is independent. That's why we multiply here. Product of red multiply product of green. And why here plus? Because this path and this path is mutually exclusive. If you go in this way, you will not go in the same time in this way. That's why this part probability sum with this probability, add with this probability. That's why this is mutually exclusive sign plus. And this and
Yes, sir,
that,
got it.
yeah, this and that are independent. That's why multiplication. Is it clear, everybody? Right?
Yes.
Okay.
So on the second draw, red and green are like independent, but on
Yeah.
the first draw, they are like mutually
Okay.
exclusive.
This red and green is independent. That's why you multiply. Plus means this path and that path is mutually exclusive. That's why you add. And green multiply red is independent. That's why this and that we multiply. Right? Is it clear?
Yes.
Again, I said this and this path and that part are mutually exclusive. That's why you add over there. But after that, this and that, with this, these are independent. That's why you multiply both of these. After that, plus and this part and that part is independent. That's why you multiply these things. Okay? Is it clear? Hello?
Yes.
Okay. Now I'm giving you a link, and after that, I explain another maths.